Good class. This is Mechanics of Deformable Bodies. Again, my name is Engineer Ralph Norman Malana, and here to give you a walkthrough of what Lecture 3 is all about. And we're going to be talking about naman yung torsion. Okay, so we're done with our lectures 1 and 2. They are very long lectures. Kung nagtataka yung bakit Lecture 3 pa lang tayo. But they're very long lectures, and hopefully this will provide you some fundamentals, especially when you're entering towards your third year, pagdating sa machine elements, machine design, so on and so forth. Okay. So, we're gonna go forth with some theory lang muna and a little bit of recap. So, mapapansin nyo, nadaanan na natin yung concepts, yung normal, shear, axial stresses, and then here we are going to talk about torsional stresses naman na. Yung bending part, we will be able to talk about that pagdating sa shear moment diagram. And of course, we'll be going to be talking about sample problems. And we'll start first with yung concept. Okay? Pagdating naman sa torsional, so basically, stress-induced dahil sa torque. Basically, yung applied torque on a circular, applied force on a circular path. And then, meron siyang moment arm rin. So, yun yung torque. Yung torque is basically a moment that tends to twist any member and its longitudinal axis. And then yung torsion basically is the twisting of movement of an object after being applied torque. Okay? So, torque is yung moments, and then yung force, pati yung applied fulcrum nun. And then yung act of being, twisting apart, that's the torsion part. Yun yung, hence meron tayong torsional angle, so to speak, torsional deflection. Okay? Mostly, pagdating dito sa exercise natin ito, ang assumptions natin when deriving torsion formulas, especially when we're gonna derive yung torsional equations nito, is that a circular yung sections niya, and yung plane sections must remain plane and do not warp. The projection upon the transverse section of a straight radial line section remains straight. It's a shaft is loaded by twisting couples in planes that are perpendicular to the axis of the shaft. Stresses do not exceed the proportional limit. Okay? The following slides is basically a derivation of the formulas that we're going to be using. Feel free to read it on your own time. So, ito yung torsional deformation, normally represented by agathy. Forget the Greek symbol here. This one. Okay, hindi yung theta, but it's the zero with a slant. It's with a slant line. Okay, and ito yung paghahati-hati nyo. And then this is yung pinaka-ideal scenario at which when one circular shaft is being deformed, so it creates a deflection done, the torsional deformation done. There are definitely applied forces dito. So meron tayong torque there, torque being applied here. But we go to your next formula, which is a series of integration dito. And one of the first formulas na malalaman mo dito, I think pinaka-familiar sa inyo dito would be yung maximum shear stress dito would be yung product ng torque times yung distance to the outer radius, or depending kung nasaan siya, in this particular case, outer radius C divided by J, TCJ. So, ang mga metrics, ang mga units natin dito ay megapascals, Newton per millimeter squared, PSI, KSI, so on and so forth. Okay? Tapos, another way of solving this particular problem is using yung radius of intermediate distance or radius of curvature, tawagan natin sa dynamics. So, that's gonna be T times rho divided by J naman. Okay, depende kung anong given dito. Now, I could dive deeper pa kung ano pa yung mga formulas dito, pero this polar moment of inertia is usually inaalam yan beforehand. It can be derived via integration. So, yung polar moment of inertia of the cross-sectional area. One of the few things na malalaman mo dito sometimes is either given yung torque, and yung J dito, malalaman mo depende sa dimensions na shaft mo. Yung shaft mo na yun is either solid shaft siya, or tubular shaft, meaning hollow. So, ito yun. We can go run through pagdating sa mga derivations dun. Pero, pag solid shaft, and if you're referring to yung variable C, okay, you can get yung polar moment of inertia ng solid shaft by simply getting the product ng pi over 2 and c raised to the 4. Or pag diameter naman yung gagamitin mo, okay, that will be yung pi over 32 diba? Times t raised to the 4. Okay? Now, pag tubular naman yung shaft, that's kind of different. So, there's two values ng outer radius and an inner radius nyo. Meron kang outer diameter and inner diameter red. Okay? So, this is the formulas you can use pagdating sa hollow shaft naman. Now, for shear stress formula, especially for maximum shear stress, ito yung pinaka-shortcut, 16d divided by pi d cubed. And then, of course, pag hollow naman siya, you just have to multiply by 16 times yung torque, times yung outer diameter divided by pi, and then the difference ng outer and inner diameter raised to the 4th. I'm not sure if I got that right in terms of English. Okay? So, ito yung mga nadagdag na bago pagdating dito. So, for one, first things first, yung isa is TCJ or is T rho over J. Yan. So, yun yung formulas na gagamitin natin. And one of the formulas na kailangan nyo maalala rin dito is, not sure kung gumagana tong pen ko, is yung sa deflection naman, hindi lang pinakita. Okay, it's not working. Next time na lang yun. We will go over naman yung deflection kasi meron siyang sariling version rin ng kanyang torsional deflection, so represented by that angle phi. Okay? Yeah. Kung yung nagkakamali, insert that. Or hindi tawag siyang empty set. Anyway. So, let's try to solve some minor problems lang muna dahan-dahan. And dinesign ko yung sample problem so that it's gonna define certain principles along the way. So, paisa-isa siya muna. For one, we'll give you a sample problem na involve yung paggamit ng variable C or basically inner radius, inner to outer radius, or yung outer diameter niya. Makikita mo dito, we have a theoretical shaft dito and supported siya by two bearings. So this one, bearings. Ang mapapansin nyo, may mga plates dito with kanya-kanyang torque. Okay? So, 42.5 kip by inch, 32 kip inch. So, that's gonna be 30,000 pounds inch, 12.5 pounds inch. And here, mayroong stress na nade-develop at points A and B internally. So, dito sa section AA na to, there are stress being developed at points A dito sa minute section na to. So, makikita nyo to. Section to, this is section AA. At point A and point B, there are stresses being involved dito. And we are to determine yung stress develop at this point. So, what do we do muna in the first place dito? Okay? One of the very first, if we're gonna go back to slides, one of the very first important variables dito is yung identification ng torque, because yung formula in terms of identifying your shear stress heavily relied on the knowing yung torque no dito. As you can see, here's a formula to. Torque times yung outer radius of the shaft or intermediate distance divided by J. J can be determined once you know your dimensions. Luckily, we have these dimensions, but we don't have yung torque. So, it's very imperative that we get yung net torque among the torques provided to us. This is a problem. So, another version ng ito, just to showcase yung another shear stress formula. So, ganun ka-importante yung team. So, normally yung dimensions, diameter, or C is usually given sa problem. So, one of the first few things about to solve really is torque. So, let's go back to problem. Okay. And here just a simple drawing lang naman. So, here, identify lang ito yung mga torques natin. And how you do is kailangan mo malaman yung internal loading natin dito. Okay. And then what you do here is find yung what is the torque essentially pagdating dito sa section na to. Okay? So, makikita nyo, hindi ko na sinama yung 12.5. Kasi ang section na kailangan naman natin malaman yung stress is nandito sa point AA. So, I'm gonna zoom it here. Dito lang tayo may pakialam. 12.5 sa kanan. Okay? So, hanggang dito lang. Yung short, ano yung net torque dito at section AA? Okay? Yun lang naman ibig sabihin doon. Let's go back. So, pagdating doon, para makuha natin, simple lang naman. Isa lang naman alam natin, the summation of moments lang naman. from this point hanggang dito sa section AA na to. Okay? So, kunin lang naman natin summation of moments, counterclockwise is positive pa rin. Okay, just checking lang yung order ko. Wait, chat lang ba? Okay, goods. So, mangyayari dito is the summation of moment lang naman, counterclockwise positive. So, first things first, summation of moment at this particular axis equals to 0. Let's just call it x. So, mangyayari counterclockwise si 42.5 kip-inch. So, that's gonna be positive. Si 30 kip-inch dito, that's gonna be clockwise. So, that's gonna be negative. And then, of course, meron tayong unknown t dito. Okay? Just gonna be on the same rotation neto. Assume on the same rotation neto. Just kasi kung clockwise is probably clockwise rin naman to. But then again, malalaman natin sa dulo, no? So, what we get here is that yung T natin would be 12.5 kip-inch dito. So, yun yung una natin nakuha dito. The next is, we need to find yung J. And as makikita natin sa shaft natin dito, it is a solid shaft. And there are several formulas to find yung J na yun as mentioned earlier. So yung J dito is yung polar moment of inertia, okay? As if you can recall, we can use tong formula na to, which is J pi over 2. J is equals to pi over 2 times C raised to the 4th. We have here yung C natin is 0.75. Okay, so yeah, we can definitely use that, yung ranges na yan. Okay, that's fine. Okay, and we can get yung polar moment of inertia nito, which is 0.497 inch to the 4th. Okay, so that kompleto na tayo, we can now determine yung shear stress nito. And recall that the shear stress can be computed as TC over J. And substitute yung known values natin dito. Yeah. So once na may determine na natin na yung may hita yun dito, medyo iba yung nag-iba yung konti lang dito, at least pagdating sa A. So pagdating dito sa section A, it has the same ranges ng 0.75 dito. So we use yung C na 0.75. Mamaya na, mag-iba yan sa B kasi mag-iba yung distansya nun at that particular point. As you can see here, kaya ginamit 0.15. So for now, so yung C natin na ginamit dito is 0.75 pa yan kasi sakto yung ranges yun doon. Yung torque natin is 12.5 kip-inch dito. Okay, 12,000. That's gonna be 12,500 pounds inch. So pare-pares lang naman yung unit natin, magiging inch to the 4th to. And then eventually magiging kip per inch to inch squared. And later on, ko-convert ko yata to much more to KSI yata. Okay, because para mas magandang tingnan. Okay, so computing that, we get 18.86 KSI. And then pagdating naman sa point B, please observe, yung C, nag-iba siya, no? 0.15 kasi, take look. Pagdating doon sa point B, ang hinahanap natin is just 0.15 inches from the center. Yun yung pinapahanap sa ating stress at that particular point. Okay? So, essentially, this is just an exercise of using this particular formula naman. No? So, makukuha natin dito is 3.77 KSI. Now, I ask you, can you determine yung maximum shear stress at 16T pi d cube? We can run it over pagdating naman sa class if you want. We can solve it now if you want. So, it's going to be 16 times 12.5 divided by pi. Tapos, d cube. So, d natin dito. That's gonna be 0.75 times 2. Raise the cube. Ang makukuha ko is around, lo and behold, 18.86 rin actually. Okay? It's actually the same. You can usually use the same formula. Now, can we use the same formula pagdating sa point B naman? Up to you to find out. Okay? Probably you can use in 0.15 inch radius and just turn it into diameter. Okay? Next, we have this naman, no? It's like actually couple moment, except meron siyang different lever arms lang dito, different distances, some 200 millimeters, some 300 millimeter. Okay, so we have a pipe here shown has an inner diameter of 80 millimeter and outer diameter of 100 millimeter. This signifies yung pipe natin dito is a hollow shaft. If its end is tightened against the support at A, using torque wrench at B, determine the shear stress developed in the material at the inner and outer walls along the central portion of the pipe when the 80 Newton force are applied uh, to the wrench. Teka lang. Let me just fix lang my HDMI kasi ito, nag-flicker sa screen ko. Okay. So there we go. So, ang maganda nito, nagbigay ako ng sagot dito. So, you can try this muna in the first place before you actually solve. And ang maganda naman dito, you have all the formulas naman dito and try to, use them well. Okay. Okay. So, yeah, let's go for it. So, for one, I like to draw it lang visually. So, just drawing ko lang 8. Ginawa ko na siya 0.3 meters or 0.2 meters para lang maganda tignan na rin. Eh, mas maikli drawing yung 0.3 here. So, like yung 0.3 meters, 0.2 meters. Alam ko yung torque. So, yung torque is usually opposing side. Kung mapapansin nyo eh. Okay, yung opposing force na generate doon. Okay? So, makikita nyo, yeah. Yung torque kasi nagkakos ng torsional stress doon and shear stress doon. So, it has to oppose use applied action force natin dito, no? So, finding yung torque natin dito, in this particular case, so this is going in a clockwise direction, it's gonna be in a counterclockwise. So, summation here, and we have negative 80 times 0.3, tapos negative 80 times 0.2 plus T, and we have 40 Newton meter. Okay, that's easy enough. Next one is we need to find yung polar moment of inertia. And as I mentioned earlier, since we have two different sets ng diameter, we have an inner diameter, outer diameter. So this is a polar moment of inertia of a hollow shaft. So we call this one magiging pi over 2 times C outer raised to the fourth minus C inner raised to the fourth. It's kind of like this. Ito rin naman siya. That's one of the formulas na pwede nyo gawin. Or you can also use yung diameter lang rin. Ako ginagamit ko lang yung C just to showcase lang naman yun. You can actually use this one. Okay. Pi over 32 naman. And then, kunin mo yung outer diameter raised to the fourth minus inner diameter raised to the fourth. You can actually use that too. But for example purposes, I'm just gonna be using yung C muna. Okay? And there we go. Ginawa ko lang siya. It's a lot longer way of computing it, pero eventually makuha ko yung polar moment of inertia as 5.796 times 10 to the negative 6 m to the 4th power. And then from here, I think we can now solve yung shear stress sa inner and outer walls niya. So what we do is and if you recall, yung formula natin dito is TCJ. That's one of the simplest formula natin dito. So, kunin lang natin yung outer, gagamitin natin yung dimension ng outer. So, C sub O. So, this is gonna be 40 Newton meter times 0.05 divided by this polar moment of inertia. Ang maganda naman dito sa polar moment of inertia, it's gonna be the same throughout naman. Okay? And then we will get the answer. I multiply this by over 1,000 squared millimeter squared, so that Newton millimeter squared. So, I have the answer na 0.345 megapascal. I do the same pagdating sa inner diameter para makuha natin yung shear sa inner. And you will get the answer 0.276 megapascal. Okay. All right. So that's it on using your formula. Actually, you can use much more simple. Since binigay yung diameter sa inyo. You can also use in pi over 32. That was the raised to the fourth. The outer raised to the fourth minus the inner to the fourth. I believe you will arrive at the same polar moment of inertia. Albeit contain discrepancy. We can try that during class naman, okay? Another concept, so if you have no more questions done, since this is a recording, feel free to ask them via email or send them over, and I'll try to answer them when I'm free. So another concept I want to introduce to you guys, yung angle of twist or the inversion deflection naman pagdating do sa axial stresses natin. And yung normal deformation natin, normal strain, and yung shear deformation. So this one, we have yung angle of twist. Okay? In case of multiple torques, okay, the angle of twist is just a summation of those torques multiplied by its respective length. So ito yun. This sum refers to the two variables above. Okay? So I can show you, for example, this one. In this particular case, we will start with yung 80. And we want to know yung torque pagdating doon sa LCD. Ano? So, what you want dito is yung distance here. So yung bibigyan natin examples na to hanggang dulo, it's gonna look something like this one. Okay. So, yeah. Pag sinabing LAV dito, so meaning yung net neto 80, and then yung 150, and then dito sa LBC naman dito, yung net ng 80, 150, and 69, and then pagdating dito sa LCD, yung net ng 80, 150, 60, and then 10. Kaya nakuha nila yung negative 10. So, or in this particular case, negative 10 na siya. But we have an example naman so that we can determine, just to show you how we use it. Okay? So, constant yung J and G dito. And yung requirement should be, they have to be on the same material lang naman. Ano? Okay. Just to showcase you examples na we have this particular gears. They're attached to the fixed end steel shaft, are subjected to torque shown below. So here we are. Okay, so A to E. You know? If the shear modulus of elasticity is 80 gigapascals and the shaft has a diameter 14 millimeter, determine the displacement of the tooth P, the P na to, on gear A. So it's just another way of asking what's the angle of deformation lang naman dito. Usually in radians ang hinahanap dito. Pero on the if kailangan naman yung degrees. Okay? The shaft turns freely within the bearing at particular B. So freely siya dito. Okay? So ito yung sagot. Okay? But just to showcase natin yung given natin, we know yung modulus of elasticity natin E is 80 gigapascals. I think that's supposed to be G yet. Yeah, sorry. That's supposed to be G. And then, I think correction, that's supposed to be G. And then yung D natin, the diameter is 40 millimeter. And we have a radius of, ito RA na to. Ito. We have here 100 millimeter dito. Okay? It's important later. So, makikita natin, recall, yung angle of deflection natin is yung summation ng torque and yung length niya divided by JG. And this one is in radians. Yung displacement, however, is just simply yung torsional, yung angle of deflection times yung radius. So, importante. Ito yung 100 millimeter dito. Yung next step natin dito is, first things first, so first na mga hanap natin dito is yung polar moment of inertia. We already have yung dimension, we have already yung radius, so we can find yung J natin gagan. So, we know yung diameter is 0.0. It's 14 millimeter yung sa shaft. So, we can just use yung formula natin is pi over 32 times this one, yung 0.014 meters to the fourth and to the fourth. That's going to be 3.771 times 10 to the negative 9 and to the fourth. Now that we know yung polar moment of inertia, we can now, so ito, this is a typo. This is supposed to be a GL. Modulus of rigidity dapat yun. My bad. We can now use yung formula na to and determine yung summation on torque. Okay, so how we do this is we go from this 115 Newton meter muna. So we know yung torque dito would be yung 150 Newton meter times 0.4. That's definitely it. Yun. Okay? So yun yung una. And then sunod nun is we have to deal with this yung A to C naman. So this is counterclockwise 150 minus 280. Okay? Para ma-determine natin yung torque dito sa gitna ng to. And then multiply natin siya by 0.3. Then finally, pagdating naman dito sa dito sa DE, so 150 minus 280 minus 40, that will be yung torque mo doon times 0.5. So let's see if tama ako. There we go. Tama ako. So sa baba yung J is yung polar moment of inertia, and then G is yung modulus of rigidity. Shear modulus of rigidity. So typo po yun. So, kung tama po ako, so dito, 150 Newton meter times 0.4. That gets easy yun. And dito naman yung torque dito sa gitna. So, sa C and D, that's gonna be 150 minus 280. 150 minus 280. So, it's gonna be negative 130 times 0.3. Tama ako doon. And then, next one, so that's gonna be Dito naman, ano, yung torque. So, kailangan natin kunin lang yung net, 150 minus 280, and then minus 40. That's negative 170. That's it. And then times 0.5, whatever your net dito sa side na to. Okay? And then from there, you will get negative 0.02 on to 1 rad. You can convert this to degrees by multiplying by 180 over pi. And then it's negative because it's rotating clockwise. Okay, yung pinaka-net na, yeah, yung pinaka-net na deflection niya. Okay, and then para makuha mo yung ano, yung displacement, all you have to do is just multiply it by 100 millimeter, and you will have 21.21 millimeter of displacement. That's it. Ilang naman. Or 21.2. Okay? You can try another exercise here if you want. And pinakita ko rin naman solution. It's pretty much the same thing rin naman. Okay? So this time around, pinapahanap yung relative angle of this lang naman dito. And ganun ulit. So we have yung given natin dito. Here we have your respective distances and yung torque dito. And lahat naman sila nakametric. We have a G of 28 gigapascals. We have a diameter of 50 millimeter dito. And we have yung loaded torques natin sa mga gears na to. And we are here to determine yung relative angle of twist. Okay, madali lang yan. Kasi yung relative angle of twist is just simply the summation of product ng torque and yung relative distances nila divided by J times G. Yun lang naman yun. So, we get yung torques na muna. So, ito. And this time around, inisa-isa ko siya. So, nagsimula tayo from dulo, A, B, C, D. Mukha lang, it just makes sense na gawin doon. So, A to B. So, dito, so sa torque A, that's gonna be 600 Newton meter. The TAB, so here, that's gonna be 600 minus 900. That's gonna be negative 300 Newton meter. Okay. And then finally, we have yung TAC naman. So TAC. So we need this one. So that's gonna be 600 minus 900 plus 1,100. That's gonna be 800. Okay. So this one is 600 times 2 meters. Ito naman, negative 300 times 3. And then 100 times 2. Okay, so let's just show it. And then yung J natin dito is gonna be pi over 32 times 0.05 raised to the fourth. You get 6.1359 times 10 to the negative 7 m to the fourth. And then we can now get na yung relative angle of twist or angle of deflection. And just like I said, so this one 800 times 2. We have yung negative 300 times 3. And then we have yung 600 times 2. Okay. Remember, you're getting the torque yung in between. Eh. So for example, so first one, TA natin is the 600 times in 2 na already. That's it. Eh. And then when you're getting yung torque AB, so yung torque dito after AB, that's gonna be 600 minus 900 kasi clockwise siya. And then multiply by yung distance dito, which is 3. Okay. And then this na naman, we get yung net dito. So 600, 900, and then negative. So no, you're right. So 800 to, this is counterclockwise. Ito 800. So it's gonna be 0 doon. So sakto yun. So here, 0.1106 rad pag sinubstitute mo lahat. And you convert it to degrees. Hope you know how to convert to degrees. It's gonna be 6.34 degrees naman. Okay. Next one is yung power transmission or basically yung work done per unit time. And as defined natin sa work is basically force times distance lang naman. In the case ng rotating shaft, basically yung formula ng work will be yung force applied plus yung arc times yung arc length traveled or equals to the force times radius with respect to the angle of the angle traveled or torque times yung data natin. Okay? So therefore, basically power is basically equals to torque applied to the arc length na yun with respect to time or simply work and bit times angular angle travel lang naman doon. Okay? So 1 watt is 1 Newton meter per second and then 1 horsepower is 150 foot-pound per second. 1 horsepower is 745.7 watts. Don't forget that. Okay? Another way to solve yung power is yung in terms of frequency is going to be the product ng 2 pi frequency and then yung torque provided you're given yung hertz or yung cycles dito. Okay? Just remember yung conversions lang dito. Okay, let's try that again. So this time around, we still have your solid shaft, but this time in application of motor. Okay, the solid steel shaft here, AB, shown is to be used to transmit 5 horsepower from the motor M to which it is attached. Okay? And the shaft rotates at 175 revolutions per minute. And the steel has an allowable shear stress of 14.5 psi. Determine the required diameter of the shaft to the nearest 1/8 inches. So this time around, we're trying to size your shaft, which is normally normal activity when you're trying to design, it's trying to select the materials, especially when you have a rated motor na. So you want to determine, okay, ano ba yung size ng shaft natin dito, okay? And then you will have to compare it with an actual shaft that is available in the market. So let's try this muna sa ito yung given natin. Okay, ito yung given natin. And first thing to do here is we know that yung power natin dito is 5 horsepower. Okay? Since we are using primarily English, I think it's helped to convert it to foot-pound per second. So, ginawa ko 5 horsepower, magiging 550 feet-pound, magiging 1 horsepower, magiging 2,750 foot-pound per second. After all, we're here to determine yung diameter. And we have yung rotation, which is 175 revolutions per minute. So, i-convert lang naman natin siya to rads per second. Okay, that's going to be 18.3.26 rad per second. And then from there, we can now get yung formula natin, which is power is T times yung W na to. So that's going to be 150. And we can determine T here, since we have power and this variable. And the T is 150.06 foot-pound. And from here, recall yung formula natin yung maximum shear stress, which is 16T over pi d cubed. So from here, we just substitute yung known values natin. 14.5 here, 150.06 here, and then of course, we will leave yung D. Isolating yung diameter, we will have 0.858 inch. Now, so be careful when you're answering, and normally iba sa inyo babaksan na to. And normally, tama po kayo doon. Pero the question is, yung pinapahanap sa inyo, determine the required diameter of the shaft to the nearest 1/8 inch. Then, hanapin niyo po yung pinakamalapit. So, you can do it manually since ilan lang naman 1/8 lang ng 1 over 8. 0.125, 2 over 8. That's 0.25. So, that's gonna be, tayo natin yung 5 over 8. Okay, 5 over 8. 0.625. Okay, kulang pa. Let's try naman yung 6 over 8. That's 0.75 bitin. Let's try naman yung 7 over 8. 0.875. Okay. Just to try lang natin. Pag namin 8 over 8, magiging 1 na yun. So, I think yung pinakamalapit na dimension is 0.875 inch. Which is 7/8. Based on measurements. Okay, ito yung babox nyo. Okay? Kalimutan ko lang yata yung box. Alright. Hindi ko na binigyan ng animation to, pero here's another sample naman when you're using yung frequency. Okay, the steel propeller shaft is at 4.5 megawatt at 3 hertz without exceeding a shear stress of 50 megapascal or twisting through more than 1 degrees in a length of 26 diameters. Okay, compute the proper diameter if G is 83 gigapascal. Okay, so pagdating dito, we have this one. So we have yung angle of detection natin 1 degree, yung max twist natin. We have yung maximum shear stress natin of 50 megapascal. And we're here to determine yung D. Okay? 1 degree in length of 26 diameters. Okay. Complete the proper diameter of GC. Okay. So, and then one of the first thing dito, remember this one. So, we have a frequency natin dito. We have 3 hertz. Since the deviation of 3 hertz, so it's going to be 2 pi frequency times T. Remember yung angle of deflection natin is TL over JG ren. Okay? And solving for torque, since we don't have in torque, so rearranging yung formula na to, we have power here of 4.5 megawatts. It's 4.5 times 10 to the 6 watt per second or Newton meter per second divided by 2 pi over 3 dito, hertz. That's gonna be 238,730.4146 Newton meter. Definitely. Okay? And then, pagdating dun, so we determine yung torque, we can now solve yung max shear stress niya. And we can solve it three ways, and two ways pala. Solve it by maximum shear stress or solve it by maximum deflection. Pag maximum stress, shear stress, magiging 16T over pi d cube, magiging 289.7147 millimeter. And we substituted do sa deflection as a TLJG, we will get a deflection of 1.8 degrees. So more than 1 degree yun. So let's try again yung deflection. So solving yung diameter ng deflection. So yung length niya dito is 26D. Yung equivalent ng isang length dito, which is 26 times ng diameter yung total length. So kaya 26D dito. Isolating it, you will get 352.08 millimeter. And assume when you substitute it here, you'll get under shear stress ng 50 megapascals. Or kundi ba equal? Okay? So I guess the lesson dito is that when you're given two parameters, whether maximum deflection and maximum shear stress, pagdating sa torsional problems, try to go with the parameter given sa maximum twisting degrees, no? Before using your maximum shearing stress capacity. Okay, but you can double check naman. So we've been, solving problems na hollow and let's try a little bit different. Let's try a combination of both. This time around, this is a hollow bronze and then steel core. So meron siyang solid shaft na steel and then hollow na bronze. And nandun siya sa loob lang naman dito. Okay, and what we're doing here is a hollow bronze shaft of 3-inch outer diameter and 2-inch inner diameter. Slip over a solid steel shaft. Yeah. 2-inch diameter naman kasi yun rin inner diameter ng bronze eh. Of the same length, so parehas sila ng length. The two shafts are fastened rigidly together at their ends. For bronze, meron siyang modular rigidity ng 6 times 10 to the 6 psi and steel naman is 12 times 10 to the 6. Now, we're being asked what torque can be applied to the composite shaft without exceeding the shearing stress of 8,000 psi sa bronze and then yung shearing stress max naman sa steel is 12,000 psi. So it's a good problem. Okay. So first and foremost, para hindi kayo malitol, let's put all the details lang muna. Isang bronze, isang steel. Bronze has an outer and inner diameter of 3-inch and 2-inch respectively, and 6 by 10 to the 6 psi ng modular rigidity. Ito naman sa steel, 2-inch diameter, and then 12 times 10 to the 6 psi. We're here to find yung torque, and ito yung parameters natin, allowable for bronze, and then allowable for steel. So the first thing we do here is I think we can find yung angle of deflection natin dito. Or angle of twist. And if we're gonna think about it, if I twist yung hollow bronze in the same direction, dapat yung steel should be twisting on the same direction rin. And dapat they should have the same angle of deflection dapat. So yun yung theory dun. Okay? So pagdating sa hollow na yun. So we set up an equation just like so. So remember yung TLJG, wherein yung deflection ng steel is equal to the deflection ng bronze. And from there, we are able to set up some equations dito. So we substitute lang some known values lang dito. And definitely, we can get yung polar moment of inertia natin dito using in diameter. Pi over 32 times D raised to the 4th. And yung isa naman is, since hollow siya, it's pi over 32 times yung outer diameter raised to the 4th minus inner diameter raised to the 4th. Yun lang naman yun. And then, we have a final equation, say equation 1. Equation 2 natin is whatever yung torque ng bronze plus torque ng steel, that should be yung total torque. Yung equation 2 natin. Okay? And kasi after all, they're on the same direction. So, yeah. So, dapat pares sa size ng steel wheel and torque mo dito. And then that's going to be your equation 2. And from there, we can, substitute na accordingly. And we will get uh, two distinct representation ng torque ng bronze and then torque ng steel. So, torque ng bronze is 0.6701 ng total torque. And torque ng steel is 0.3299 ng total torque nila. Okay, hindi pa tapos doon. The next step naman is, we're gonna go, so now we're gonna be using na yung shear stresses natin. And since we now have our respective torques na dito, we can just apply them accordingly. So for bronze, it's gonna look something like this. Since the torque ng bronze, 0.6701 T. So that's gonna be 16D DO divided by pi DO fourth minus the fourth. And we just substitute yung T doon, which is there we go. I isolate pala yung T there, and makuha natin yun eventually. And then we will get yung T as 4,232.44 foot-pound. So steel naman makuha natin is 4,761.4317 foot-pound. Now the question dito is, which torque are we supposed to use? And that is a topic when we return. If you have an answer, feel free to, provide me in the email.